Good morning, everyone. Okay, I'm doing this video because of the cancelled class we had on Tuesday, the Maths 121 class we were to have on Tuesday. So, this is the course outline you're seeing here. Starting with functions, we have definition of functions, types of functions, inverse function, composition of functions, domain of functions, range of functions. So basically, I'll be talking about this first, then this later. They're very simple terms. We just have 5 things to be worried about. Just 5 topics to be worried about, but I don't think it's worth being worried about. Looking at it, it's simple, easy to grab. Okay, starting with definition of functions. Functions are simply relations or mappings that connect an input to its output. Okay, I believe that is far simpler said than done. Okay, so this is the concept of functions. I sent a video earlier concerning, okay, it's talked about an orange, for instance. Then let's say this orange, for instance, you want to extract juice from it. So you squeeze it, or let's say you blend it. Yes, let me use blend. You blend your orange, and let's say finally you get those particles and whatever you want to get. Then you now come and sieve it to get your juice. This is the process we are talking about. Now the orange is the input. This is the output. The output of this grinding or blending process. Okay, it's this simple. So this serves as the function. It is the gap in between the input and the output. The output can also serve as the input in another case, but here the process will be sieving rather than blending. So it's this simple. And here we have the juice. This is our output 1 and our output 2. So this is basically it. This input in mathematics for functions, we call it x. The output, we call it y. Okay. So considering all these factors, we would say that this output is dependent on the input. Through this process, it is dependent on the input and this process. Very important. But it depends entirely on the input. So saying directly this is independent, the independent variable, and this is the dependent variable. However, this is how a function looks like. Okay, this is the expression for a function. So a function looks like this. it has an x value which is independent, and the y value. This function gives the y value. So this y value is dependent. Okay, I believe everyone has followed to that point. Okay, so this is quite simple, independent, and this is dependent. Function of x, so I would say it's like the image of x, y, and the rest. Okay, so going further, we've looked at the definition of functions. We've tried to express what a function looks like. Most time it may not look like this. This is trying to show that there is a relationship between y and x. So it's just the relationship we are looking at. And importantly, very important, now we have what we call the domain, and we have what we call the codomain. Very importantly, we had been taught about sets last semester. So this is the guiding tool. Yes, guiding tool. So the domain is a set of numbers, set of x values. Are you with me? A domain is a set of x values. Codomain or range is a set of y values. Are you grabbing it? Yeah, I believe. By God's grace. So in the normal how do you call it? Set builder notation, would be having something like this. X is such that, okay, domain is equals to, open bracket, x is such that x is a member of whatever. It depends. And the range is such that y is a member, okay, I have x here, of y. So what I necessarily mean by this is x is an element of the domain and y is an element of the range. Okay, and y is the element of the range. So is this simple? So when we talk about functions, function is the relationship between the x values and the y values. Most times the y values are called the image of the x value. It's just like a mirror kind of interaction. Okay, let's say a boy is looking at himself. This is the boy here. But it depends on the mirror he's looking at. Remember, we thought something like convex mirror, concave mirror, and the rest of it depends on which particular mirror he's looking at. It will now determine how he will look on the mirror. Let's say here he will look kind of coffee towards himself, a coffee or and here he would look kind of bending towards this side. So it all depends with the type of mirror. This type of mirror is now what I regard as functions. And this is the input, which is the x value, and the image, which is the y value. So that's basically the concept behind functions. Sorry for the inconsistency in camera. Okay, so I think we are done with defining functions. All in all, just know that it relates x to y. Finish. This is the function. It relates x, in fact, generally equals to y. It relates x to y. Okay, so we move on to the next phase, which is types of functions. So basically, we have how many types of functions do we have? Okay, we have the polynomial function, types of function. We have the polynomial function. Okay, this has to do with the powers. Exponent, yes, exactly. The best word for it. Exponent. So when we are looking at 2x raised to the power of 2, this is a polynomial. For it to be a function, y is equal to 2x raised to the power 2. The power here makes it this exponent here, the power, makes it a polynomial function. So it's basically simple. We have other examples to be y is equal to 2x raised to the power 3 minus 4x and so on. We'll be mixing the polynomial and other types of functions, even expressed as rational numbers and functions. But let's just head on. Number 2, we have, okay, they decided putting this rational function. As the name rational is from the word ratio. Ratio. So ratio, when we talk about ratio, what comes into your mind first? Division, right? When we have 1 is to 2 is equals to 1 over 2. So it's basically division. So examples of functions, we have y is equals to 1 over x plus 1. This is a rational function. Let's try and see an example that you can see the polynomial function and the rational function. Let's say, for instance, we have x is equals to x squared plus 2x divided by x squared plus 4. This is a combination of both the polynomial and the rational. Okay, moving ahead, we have the root function. Well, some people might argue if it's not also under polynomial, but there's a vivid reason why they brought it out to look this way. Don't worry, we'll get to talk about it later in the class, in the video. Okay, so root functions, from the word root, we have, when you see the word root, you just remember, oh yeah, square root. We have cube root and the rest of it. So basically, it's just talking about the root system like this. Let's say we're having this plus 2, let's say y is equals to this. This is a root function. A root function. So it's this simple. And I came to realize, should I say realize? Yes, discover, realize. Okay, I came to find out for myself that these are also called radicals. I was amazed when we have the roots. So we'll be using the word radical at some points in our learning instead of root. So please note. And another thing to note, if this is, let me write it down here. If this is your function, this implies that this entire thing here is a radical, and that's the one inside this root, is the radicand. So you take note of those terms just in case. Then this root here, I believe looking at this is root 1 over 2, right? This raised to power 1 over 2. This is the same thing as this. We want to remove this. Want to express it this way as an exponent. So it will be looking like this. So this 1 over 2 is called the index. Just like saying power. Though, yes, power. That's it. So we have other functions like the absolute value function. Sorry for my handwriting. I'm a bit tired, but I'm very sorry. Okay, so this one is far simple because it's just a little thing to grab. Let's say we have a function inside plus let's say 3 absolute. So this absolute feature that we are seeing here, this strikes simply show that anything that comes out from here. Can anything come out from Nazareth? Okay, but anything that comes out from here must be positive. At the end, what I'm saying at the end is when including this, it must be positive. That means y must be a positive value. Must be positive. Okay, which other one do we have? I guess I'll just have to continue. So for now, we've gathered polynomial functions, we've gathered the rational functions, we've gathered the root function, and we have a absolute value function.